Well, we have heard a lot about site surveys, and we're going to keep talking about wireless site surveys. So in this video, we're going to lay a foundation for defining what exactly a site survey is, what the goals are, and how we go about doing them. Wireless designs have a dimension to them that no other type of network design has, which is the concept of RF signal. We've got to worry about the radio frequency signals in our environment and where they're going to go and whether they're going to reach to the corners. And so as a result, we need to know where every single access point should be placed. So AP placement is a very important part of every wireless design. Well, I can't know for sure where each access point is going to go unless I test and figure it out myself. And there's a lot of methods to this, but the goal is ultimately the same. It's to determine the optimal placement for the access points that gives me the coverage that I need. And eventually we're also going to talk about not just coverage, but capacity, because we need both of those to be considered as part of a modern wireless site survey. So how exactly do we go about doing this? Well, first and foremost, we're going to leverage some kind of software tool. And there's a lot of software packages out there that accomplish this. In my experience, the two more popular ones, I would say, are going to be Ekahau as well as AirMagnet. And the idea here is that we're going to walk around the environment and figure out where certain signals map as far as the floor plan is concerned. And so the goal is to create a heat map. The heat map is going to look like any kind of temperature map, maybe a weather map that you've seen, that in this case is going to show the floor plan. And so we've got a floor plan here, we've got a bunch of rooms, we've got the doors, the hallways, etc. And so ideally what we're doing is we're walking around, we're recording signal strength, and it's going to map the heat map on top of this. So we've got wireless signal that looks like this, and wireless signal that looks like this over here. And we see that it's maybe weaker in the corners and stronger right next to the access point. And so that is the ultimate goal of a site survey. Now, a site survey is always going to come with a set of requirements that must be defined ahead of time, because we've got several different types of wireless networks that we could end up implementing, and the site survey needs to reflect that. For example, we need to define whether there are real-time applications in use. And the most common, most prevalent real-time application that we need to concern ourselves with would be voice over IP. Do we have voice over IP calls happening, and do we have video calls or some kind of video application? Or any type of real-time application really is what we care most about. Because if we do have real-time applications, then this is going to affect many things. It's going to affect the overlap of our different cells. It's going to affect the overall signal strength as far as what's considered to be a valid signal strength and what is considered to be a not valid signal strength. And then packet loss is also going to be affected by these types of decisions. And so if we don't have good enough packet loss percent, in other words, if the percentage is too high, then at that point it might have worked for a data site survey, but it's not going to work for a real-time services type of survey. The other question we might ask is, are we going to need location services? Because if we're going to be tracking devices and where they go, this changes where we place the access points as well. We form this sort of cage of access points with location services. So if we don't have location services in place, we might have our access points that look something like this, where we're trying to service the entire area and get coverage everywhere. I know my circles didn't quite cover everywhere, but for the sake of this demonstration, let's just assume that they are. Location is going to change that in that we're going to place access points around the perimeter as well and try to form triangles. And so the triangulation concept is going to come into play here. And so depending on whether we need location services or not, naturally this is going to heavily impact our AP placement. And we might end up having to do a survey that looks like this versus one that just supports real-time applications. And lastly, we might just find that we're deploying a data network. A data network these days is pretty far and few between that we have these actually. It means that we're not having any kinds of real-time applications and we're not deploying any location services. So this is basically just a vanilla type of site survey, which is going to look a whole lot like the one on the left here. However, our overlap and our signal strength and our packet loss are less stringent than they would be if we were deploying voice over IP. So ideally, what we're going to do is we're going to perform an on-site walkthrough in order to do the site survey. And so this typically actually involves some kind of AP on a stick, I like to call it. An AP on a stick means that we're literally mounting an access point to a stick. And so we've got the access point hanging here, and it needs to be mounted as if it's on the ceiling. We want the access point to be as close to the ceiling as possible, so we want this to be a pretty tall stick. And then maybe this is on wheels in some capacity, and so we're rolling it around. And what we do, assuming we've got some kind of battery on here that powers the access point, is we leave this in a place, and I with my laptop or my tablet or my device or what have you, I'm going to go on a walk. And so, yeah, this is me taking a walk, I suppose. I don't know what happened to my leg there, but ultimately I'm going on a walk and I'm letting the software know that, hey, I'm in this part of the map. And so I click this spot and it maps the signal to that location, and I map myself all throughout this domain. And then I go and I move my access point to a different spot, and that helps me to determine where the access points are going to go. And so this is the ideal type of survey that we need to do. However, there are a couple of roadblocks to this. First and foremost, it assumes that I have access to the location, which I might not have access to. It might be overseas. It might be too far away to drive, or for maybe it's a dangerous chemical plant or something like that. And so I might not have access. And second of all, it might not be ready. I once showed up for a wireless site survey and literally the walls for the building were not up yet. That was a gross miscommunication between me and the customer. However, naturally, there's not much point in doing a wireless site survey if there are no walls in place, because when we install the walls, it's going to completely change the RF signal. And so that site wasn't ready. And therefore, we need to make sure we not only have access to the site, but we need to make sure that it is ready to go, that there's no walls that are going to be built after the site survey is completed. Otherwise, the site survey is going to be very inaccurate. So in the situation where one of these is not actually applicable, we can use what's known as a predictive site survey. A predictive site survey is going to leverage software in order to, well, predict what the wireless signal is going to look like. And so we can ideally use a software package like one of these we mentioned over here. By the way, Cisco's Prime Infrastructure will also do a predictive site survey. But what we can end up doing is we upload a map, a floor plan. And so we've kind of got this deal that we had on the left. So we've got some rooms on here, etc. And so I end up mapping. I have no idea what's going on with this floor plan. There's no hallways in there. But either way, I actually tell it where the walls are. And so I say, okay, these are the walls. They are drywall, for example, or maybe they're brick or whatever the situation is. And the software is going to be able to interpret the RF propagation through these concepts based on just mathematical operations. And so I can sort of drag my access points around and say, okay, I'm going to maybe place the access points here, and it runs a predictive survey, and it tells me what that RF signal is going to look like. Now, as we might imagine, if we do a predictive survey, the accuracy isn't going to be quite what we'd get out of the on-site type of survey. However, sometimes it's the best we can do. And so let's make sure we're taking advantage of this software in order to give us something. Now, in this situation, it's highly advised that when we do our design, that we include some amount of spare access points. Because at this point, we might have to make some underlying assumptions that don't end up being true. And that's nobody's fault unless we didn't think about this in advance. So it's better to include some spare access points to say, hey, you know, we do actually need a fifth access point right here. Where are we going to get that? I don't want to have to go back and ask for more money in order to buy another access point. Instead, I'll just tap into my spares, which we all agreed in advance we would purchase. Now, regardless of whether we do an on-site survey or a predictive survey, either way, we're going to want to make sure that we do a post-deployment survey. Meaning that once the access points are in place and the environment is ready to go, before we go live, we want to do one more survey. We want to establish one more heat map that tells us what the actual signal ends up looking like. And so we can do a few things here. First of all, we can make sure that it did end up being good enough. And so, hey, yes, we're either good, or hey, maybe we need another access point somewhere, which once again is more reason to have a few spare APs in the deal. However, the other thing we can do is we can take this back and look at our methodology for performing the site survey, as well as possibly the predictive site survey, if that's what we used, and try to figure out, okay, we had a few dead spots in here, what happened? Oh, we made a bad assumption, or maybe the site wasn't as ready as we thought. And we can take those as lessons learned into the next site survey that we do. But ultimately, this part right here, this post-deployment survey, is going to tell us whether the wireless environment is ready for live production traffic before we actually put that live production traffic in place. So the goal of the site survey is that we want to create one of those heat maps to help us determine what the wireless coverage is going to look like as part of our design. And so ideally, we can get on site and do a physical site survey, but that does require that we have access to the site, and it also requires that the site is ready. And if either of those things isn't in place, then we can do a predictive site survey as well. Now, lastly, once the implementation is done, we should always do a post-deployment survey. That's going to tell us what the actual environment looks like. It's good for documentation as well in case something changes in the future. But at the same time, it's going to tell us whether or not we're ready for live production traffic to get on here before we actually flip the switch and put it on there. I hope this has been informative for you, and I'd like to thank you for viewing. Thanks for watching. Be sure to click here to subscribe to CBT Nuggets and click the notification bell to make sure that you're aware of every time we post new content. If you're interested in a career in IT or you want to brush up on your IT skills, then swing over to our website, and while you're there, be sure to sign up for a free trial.